Hey, and welcome back once again. Today we're talking about Mathematical Standard 8 EEB 5 again, but this time we're going to focus on the slope of a line. Our learning target is to interpret the letter M as slope, as well as understand that slope represents the steepness of a line in terms of rise divided by run. In order to be successful at this, first I can read a graph. We talked about this yesterday. When you look at a graph, you should be able to tell me what all the coordinates are just by looking at it, what the value of x is, what the value of y is. Secondly, I can create a ratio of vertical distance divided by horizontal distance. So we're going to need to be able to count how many units up, we're going to need to be able to count how many units across, and create a ratio knowing those proportions. And lastly, I can interpret slope in terms of the context. So not only are we going to learn what this word slope really means, but we're going to be able to interpret it in real life words. So let's take a look at our little intro here. It says slope describes the steepness of lines in the coordinate plane. The slope of a line is the ratio of vertical change to the horizontal change. So for instance, if we were to plot 2 points, let's say 0, 0, and 2, 2, and connect a line through those points, we should be able to calculate the slope of that line, or the steepness of that line. It's very important that we connect slope to steepness. This is very, very important. Slope represents a number that describes how steep a line is. So literally think about a ski slope. The steeper that slope is, the larger the value, the number is going to be that represents slope. I usually connect the word slope to thinking about a ski slope. So when I think about the vertical change from point to point, and again I'm going to talk about the point 0, 0 and the point 2, 2 that lie on this line. When we talk about the vertical change, think about from 0, 0, how far you have to rise to get to the next point. So I had to rise 2 units to get up to the next point. Then I had to run 2 units to get from point to point. So I went from 0, 0 to 2, 2 by rising 2 and running 2. That means that the slope of my line, I'm going to create a ratio. Slope is equal to vertical change, which in my case is 2, divided by the horizontal change, which is again 2. Make sure whenever we write slope, we should always reduce our fractions. 2 over 2 is the same as saying 2 divided by 2, which is 1. So the slope of this line is going to equal 1. Now, if I were to draw a steeper line, so let me get rid of some of my drawings here. If I were to draw a steeper line, then I should see my slope increase. So let's say now instead I plot the points 0, 1, and let's make it really, really steep, 1, 6. If I connect a line through those points, I get what looks like this. Okay, so there's my line. And now I want to calculate the vertical distance, which I start my pencil on the first point, and then I just draw vertically upwards up until I'm as high up as the other point. So I just rose up 1, 2, 3, 4, 5 units. Then I have to calculate my horizontal change. My horizontal change goes from here over to the point, which was only 1 unit. So my slope here, vertical change was 5, the horizontal change was 1. So the slope here is 5 over 1. If anything's over 1, you can always simplify this to just 5. So the slope in this case is equal to 5, which makes sense because we drew a much steeper line. If I was a skier going down this ski slope, I'd be much more scared than the line that I had drawn previously. And since 5 is greater than 1, that makes sense. It's a steeper line, thus a larger number. So we're going to be really studying for the next few days this word slope, slope of a line. Now let's apply this to the first example. So let's start with the first example. It says identify the slope of each line. So the slope was supposed to be a ratio of rise divided by run, or the vertical change divided by the horizontal change. So we need to look at the points that all of these are highlighting, meaning whenever I say a point is highlighted on a line, anytime they bold a point like that and make it a really big dot, they're just trying to show you where that value is. But really there are points all along the line that is drawn. Okay, but they're only highlighting a few points because you can calculate the slope from only 2 points. You only need to look at 2. So let's look at the vertical change of the first graph. So from the leftmost point, just draw a vertical line up to the highest point that the second point is at. So that distance right there is no higher than the second point, which this distance was 2. We went from 0 to 2, so that's 2 units. Now the horizontal distance, starting at that same spot, if we go horizontal, we count 3 units. 1, 2, 3. So the slope of the first graph, again, just to remind you, let me write this down. Slope is equal to the vertical distance divided by the horizontal distance. Sorry if my handwriting's a little sloppy there. Vertical distance divided by horizontal distance. So for the first graph, I have the vertical distance is 2, and the horizontal distance is 3. So the slope of the first graph is 2/3. Now I'm going to do the same thing for the following 2 graphs, starting at the leftmost point and then going to the rightmost point. So putting my pencil on the leftmost point, I have to travel upwards to get to the rightmost point. I stop at the highest point, and then I figure out the horizontal distance. So I'm basically just drawing a triangle. I'm following along the grid line completely vertical until I'm at the same height as the second point, and then I draw the line horizontal until I reach that second point, so that I can calculate, well, this is 1, 2, 3 units, and then this one is 1, 2, 3, 4, 5 units. So again, the slope here is the vertical distance, 3, divided by the horizontal distance, 5. So the slope of this line is 3/5. All right, I got one more here. One thing to notice, the difference between the first 2 graphs and the third one, this is a different type of graph, is that it is sloping downwards from left to right. You want to make sure you realize that this one is a positive slope, this one is a positive slope because it's going upwards from left to right. Upwards from left to right. Okay, read a graph just like you read a book. You read it from left to right. So if you notice that the points are ascending from left to right, that's a positive slope. If you think that the points are descending from left to right, then that's a negative slope. So I know that this slope here, that should be a negative slope, but I need to calculate it. I like to also put the triangle below when I know that the slope is going to be negative. So I'm going to put my pencil on the leftmost point, and I'm just going to make a vertical line for my vertical distance down as low as the second point went. Then I'm going to draw a horizontal line from there to create a triangle, and I'm going to count the distance. Well, this one only had 1 unit. The vertical distance was only 1 unit, and then for the horizontal distance, 1, 2, 3, 4 units. So when I calculate this slope, technically I should put a little negative on that one because we fell 1 unit. We didn't rise 1 unit. So my slope is -1 for having fallen 1 unit. That's the vertical distance. And then the horizontal distance, we still went in the right direction. We went right to get that 4, and right is always a positive direction, so that's a +4. So the slope for this third line is -1/4. So now let's have you take a look at the U-try. All right, so as a quick extension for what we just talked about, slope is always the ratio of the vertical distance divided by the horizontal distance. So it's possible that two people saying something differently could mean the same thing. For instance, let's take the fraction 4/2. That's really the same as 4 divided by 2, which is 2/1. We can figure that out by reducing or simplifying the top and the bottom, the numerator and the denominator, by dividing each of them by 2, and that's what gets us 2/1, or just 2. So these two things are equivalent. 4/2 is equivalent to 2/1. Now, that's true also when we create slopes. In fact, another way we can create an equivalent ratio is by manipulating negatives. So let's read this situation and see if these two friends are really saying the same thing. It says, one of your friends describes the slope of a line as the x-coordinates increased by 2, the y-coordinates decreased by 5. Let's translate that. So the x-coordinates, let me get my highlighter. Okay, the x-coordinates increased by 2, y-coordinates increased by 5. Well, if we think about our definition for slope, let's write that down again so that we remember. Slope is the vertical distance divided by the horizontal distance. And vertical, the vertical axis is the y-axis. So we really have the y's divided by the horizontal distance. The horizontal axis is the x's. So we're really doing the y's divided by the x's. I don't know why I wrote a squared. It's supposed to be x's, apostrophe s. Okay, so I can take that literally and translate it into a proportion. So in this first situation, the ratio would be the y's on top, which y's would be decrease by 5. So decrease would be negative and then 5. And then we would want to put it over the horizontal distance, which it says the x-coordinates are increased, that would be a positive, by 2. So this is just a positive 2 underneath. Now let's create the slope for the other friend and see if they really mean the same thing. So in the other friend, we have the x-coordinates were decreased by 2, and the y-coordinates were increased by 5. So let's interpret that now. The y-coordinates go on top, so let's look at the y-coordinates first. It says increased by 5, so that's a positive 5 this time, positive for the increase. And then we need to put it over the x's, and it says decrease by 2. So decrease would be the negative, so that'd be -2. Well, now this is what I'm talking about. Is -5/2 equal to 5/2? And the answer is yes. If you were to plug in -5 divided by +2, and I'm actually going to do that in my calculator, and I get -2.5. If I plug in +5 divided by -2 in my calculator, I still get -2.5. And that's because a negative divided by a positive is still a negative. Same thing goes if you switch the order. A positive divided by a negative is still a negative. If the signs are different, when multiplying, then the result is negative. So it doesn't matter which one you say is negative, whether it's the numerator is negative or the denominator is negative, it really makes the entire number itself negative if one of them is. Now, if they shared the same side, if it was -5 divided by -2, a negative divided by a negative is positive. So if you have the signs being the same, that's positive. If you have the signs being different, that's negative. So in this case, both friends would have been describing the same line. Now let's move on to an alternate method that we can use to find the slope. Now this method is mainly used when you're given coordinates. When you're given coordinates, a lot of times they're going to be whole numbers, but sometimes the coordinates could be decimals or fractions. That's when this method really comes into play. Also, if you don't have a picture of the graph, what if your points aren't graphed down? I don't want you to have to go grab graph paper in order to count the slope. I would rather you have a quick and easy formula that you can just plug into. So let's talk about what this formula could be. Again, my slope is the change in the y coordinates divided by the change in the x coordinates. That's the same thing as saying vertical distance and horizontal distance. It's just a different way of writing the same thing. Change in y coordinates versus change in x coordinates. So let's talk about what the change in y coordinates could be. Well, let's talk about the leftmost point. So this point right here, the y coordinate of the leftmost point The y-coordinate of the leftmost point is 3. The y-coordinate of the rightmost point, which is this one, the y-coordinate would be 0. So how did it change? It went from 3 to 0. So we subtracted 3 in order to get there. Now let's look at the change in x. If we look at the leftmost point, which is this one, the x-coordinate is -4. If we look at the rightmost point, which is this one, the x-coordinate is 2. So how do we go from -4 to +2? We would have to add 6. So now I'm ready to create my ratio. My slope would be the vertical distance, or the change in the y, which is -3, divided by the horizontal distance, or the change in x, which is +6. Now I just have to reduce. -3 divided by +6. Both of those numbers are divisible by 3. So I can reduce this fraction down to -1/2. So the slope of this line is going to be -1/2. Again, I could have just counted this. Okay, if I look at my graph, I see 1, 2, 3, 4, 5, 6 units on the horizontal. I also see 1, 2, 3 units on the vertical. Okay, but it also goes downwards, so that would be a -3. So I could just look at the graph and see, okay, my vertical distance is -3, my horizontal distance is 6, and then set up the same ratio. But again, this method is really useful when 1, your points have decimals in them, or 2, they do not provide you a graph. So now let's take a look at the second example. It says, what is the slope of the line that passes through each pair of points? So I'm going to use my alternate method for each one of these. And I'm going to write that at the top just in case we forgot. It's going to be that slope is equal to the change in y over the change in x. Now, if you notice, I could actually create a formula out of this. In the alternate method, all I really did was take this number from the right point and subtract this number. 0 minus 3 is negative 3. 2 minus negative 4 is equal to positive 6. So the formula for this would be y2 minus y1 over x2 minus x1. Write that at the top. It's a very important formula. This is the slope formula when you are given coordinates. Okay, if you need to, circle it, put arrows next to it. It's a very, very important formula, and it makes it easy to calculate slope when you're not given a graph or you have decimal points. So what do I mean by those little 2's? Why are they little? Why are they to the right? They almost look like exponents, and believe me, they're not. They're just saying where the actual coordinate is coming from. So, for instance, let's zoom in just on this first example. What the x1, x2, y2, y1 means is if this is the first point and this is the second point, then there's an x and y in each of those points. Let me make my pen a little smaller here so I can write it better. Okay, so I'm going to write first that this is the x value that comes from the first point. This is the x value that comes from the second point. Now I can label the y's. This is the y value that comes from the first point. This is the y value that comes from the second point. And now I'm ready to plug into my formula. I'm going to write slope. And you know what? In fact, instead of writing the word slope, you can always write just the letter m. The letter m represents slope. Yesterday we talked about how m represented the word multiplier. Well, slope is going to be the same thing as the multiplier. So I'm just going to write m instead of the word slope. M is equal to y2 minus y1 over x2 minus x1. And I'm going to plug in the values from the actual point into this formula. Well, the one that I labeled y2 is this one. So y2, which is 4, minus y1, which is 2, divided by x2, which is this one, 2, minus x1, which is negative 3. Now, please make sure you write that negative in there. I should have a minus negative 3 at the bottom. It's always minus. Okay, the formula is always to subtract the 2 points. But if you're subtracting a negative, don't forget to include that sign right there. Just because you're already subtracting it doesn't mean you don't write the negative. When we simplify this, 4 minus 2 is 2. And whenever you subtract a negative, it turns into adding a positive. So really I'm doing 2 plus 3 here, which is 5. So the slope of the line that passes through the 2 points listed above is 2/5. Let's try this 2 more times. I'm going to go a little faster on these 2, and then I'm going to have you guys try one yourselves. Okay, so I'm just going to use the formula each time. First I'm going to label, then I'm going to plug in. So this is the x from the first point, x from the second point. This is the y from the first point. This is the y from the second point. M is equal to y2 minus y1 over x2 minus x1. I would highly recommend on each problem that you do rewriting this formula because then it will help you commit it to memory. Now I'm going to plug in. So y2 is negative 5 minus y1, which is 1, over x2, which is 8, minus x1, which is 6. So the slope of the line that passes through these 2 points, negative 5 minus 1 is negative 6. 8 minus 6 is 2. I should definitely reduce that down before I circle my final answer. Negative 6 divided by 2 is negative 3. Last one. I'm going to do the exact same thing. Here's the x from the first point. Here's the x from the second point. Here's the y from the first point. Here's the y from the second point. M is equal to y2 minus y1 over x2 minus x1. So y2 is 4, y1 is 4. x2 is 1, x1 is negative 2. Now I simplify. 4 minus 4 is 0. And then the minusing of a negative, I'm really just doing 1 plus positive 2, which is 3. Now in this case, nothing divided 3 times is still nothing. So the slope here is 0. One thing I want to add, if you ever get a slope where the denominator is 0, that we would not call 0. That we would call undefined. But we will talk about that more in a little bit. Let's have you guys go ahead and try your second U-try. This one says, the building code for a ramp recommends the ramp should rise no more than 1 inch for every 12 inches of length. Does the ramp shown meet the building code? How do you know? So we need to create a proportion having to do with the information they tell us. So let's take the requirement of no more than 1 inch for every 12 inches of length. Sorry, that was a rise of no more than 1 inch for every 12 inches of length. And let's create a ratio with that. So remember, slope is rise over run. So I'm going to write that down again. M is equal to rise over run. So in the situation, our slope is equal to a rise of 1 and a run of 12. It should not exceed 1/12. If we create a ratio for the ramp itself that we see in the picture, I see a rise of 8 and I see a run of 70. Let's create a ratio out of that. 8 is the rise, 70 is the run. So now we need to compare these two numbers. Basically, the question is saying that the numbers here on the ramp should not be more than the actual requirements. So I want, if I were to write 1/12, I would want that to be more than 8/70. Now you can reduce the 8/70 if you'd like. Both of these numbers are divisible by 2. You should always reduce your fractions. So really, the 1/12 should be greater than 4/35. Now it doesn't matter if you actually reduce down the fraction because we're just going to change it into a decimal anyway and compare those two numbers. So if I type in 1 divided by 12, I get 0.083 with the 3 repeating. I want to know, is that greater than, and I'm going to type in 8 divided by 70, or I can type in 4 divided by 35. It should give me the same answer. I'm getting 0.1142857,143, and it goes on. So now I'm really just asking, is this true? Is 0.083, with the 3 repeating, greater than 0.1142857,143? Well, I'm going to say no, it's not greater. Okay, this number here is not greater than this number here. And it says it has to rise no more than the following. So since the 1/12 is not greater than the 8/70, then this ramp does not fit the code. Does not meet code. Sad day for this ramp. It was not built correctly. All right, so now go ahead and try your U-Try.